Okay. Hello, everyone. My name is Sérgio Salles. I'm from the University of Campinas. We are now starting, this is the first webinar that we are organizing. This is organized by our research group, which includes, it's the group on research on studies on innovation, organization of innovation and research, and also with the project in CISPO, which is another project turned to innovation systems in general. This today we are going to present a seminar about future of future studies. Actually, what we are going to present and to discuss here is the use of big data, machine learning, these new tools in order to improve or to increase or to base perspective, technological perspective, scientific perspective, market perspective, whatever. And for this, we have here today one person to present, which is our ex-student, ex-PhD candidate, now a PhD, Dr. Vinicius Muraro. Dr. Vinicius Muraro is going to present this theme, which is part of his thesis, recently defended here in this Department of Science and Technology Policy at Unicamp. And also we have the pleasure to count with Professor Abdulah Gok, Professor Dirk Meissner, and Professor Nicholas von Ortes. Professor Abdulah Gok is a senior lecturer and Chancellor's Fellow at the Hunter Center for Entrepreneurship, Strathclyde Business School in Scotland. He's also honorary research fellow in the Manchester Institute of Innovation Research at the Manchester Business School. His research areas of interest are emerging technology, science and technology policy, enterprise and innovation policy, and social innovation. Thank you, Professor Gok, for coming, for accepting taking part in this webinar. And then also the other commentator is Professor Dirk Meissner. He teaches at the Higher School of Economics in the National Research University Moscow, Russia, where he's a professor and researcher in the Institute of Statistical Studies and Economics of Knowledge, and also head of the Laboratory of Economics of Innovation. Professor Meissner's areas of interest are STI, Science, Technology, Innovation Policy and Management, Innovation Systems, and Foresight Studies. He also, Dirk has collaborated with us in our department in the past 4 years. And thank you for coming. Also, thank you for accepting taking part of this seminar, Dirk. So let's go for the presentation. I invite Vinicius Muraro to present his thesis, the part of his thesis in this so interesting subject that is, what is the future of future studies? Please, Vinicius, the floor is yours.
Okay, thank you. I will share my screen. Can you see my screen?
Yes, we can. So please just now, okay. Now we see the full screen. Thank you.
Okay. So first of all, I'd like to thank Professor Gok and Professor Meissner, and also Professor von Ortes for being here and comment my research. Also, I'd like to thank Professor Sérgio Salles for giving me this opportunity to say about my research again. And so this research is part of my PhD dissertation. The title is Future of the Future Studies, the Trends of Using Big Data in Machine Learning. I will present a brief introduction of the subject. Then I will present the research questions and the objectives of this research, and then the fundamental concepts, the methodological approach, the results and the discussion of these results, and finally, the final remarks. Okay, so it this research started about in discussions with me and Sérgio Salles about the future, about the impact of big data and machine learning for future studies. So we begin this introducing the theme of future studies. So since the post-World War, the future studies became a very useful tool for forecasting technological trends, mainly for policy, strategy, or decision-making. However, the new paradigms of data, it means the data on massive scales and the processing capacity, we can say that big data and machine learning, has changed how institutions and people and governments deal with data. And also these tools have impacted the future studies, methodologically, conceptually, and this is the start point of this research. So given the evidence that big data and machine learning have important effects on the availability and processing of large amounts of data, to what extent these effects will affect the capabilities, the methodological approach, and the tools employed for future studies, and which roles big data machine learning may play in this permanent endeavor of dealing with uncertainty. So the objective, to answer this question, the objective of my research was to identify and analyze the trends of future studies for science, technology, and innovation from the perspective of big data machine learning, and how it will change the methodological approach and the conceptual approach. And for specific objectives, the first one is to analyze the status and potential of big data machine learning tools for prospective analysis, discuss how the concepts, how big data machine learning will affect the understand the concept of uncertainty in future studies. So you see that when you think about the future, uncertainty is always present. And the third specific objective is identify the main approaches, the methodological approaches of big data machine learning in future studies. So, as fundamental concepts, we talk about future studies, uncertainty, big data machine learning. So we'll talk a little bit about this. Future studies. Thinking about the futures is inherent to human society since ancient times. But before people thinking about the future, think about mysticism and prediction, and always think about that determinist future. However, nowadays we have very different approaches for dealing with the future. So we have forecasting, prospective technology assessment, future-oriented technology analysis, horizon scanning, and also foresight. Foresight now is like a general term for thinking about the future and projecting the future with other actors in order to share the same vision of the future and also build this future together. And all these methodologies to think about the future has one simple point, one simple base. It was to deal with the uncertainty of the future that we don't know. Here you can see the foresight diamond from Popper. So it's explicit some methodologies for future studies based on interaction, on evidence, on expertise, and creativity, right? And also I bring here continuous foresight processes from Popper and Miles that defines 5 phases for the foresight process. So in the first one, the pre-foresight, people define the rationalizing objectives of the study. On recruitment phase, the foresight core team recruit new members and collecting data. The generation phase is to generate the prospective insights, the future trends, and shared visions of future. Action is the real objective of most all the foresight studies now is to take these results to inform policy, strategy, and decision making. And the last phase is renewal. It's to monitor and evaluate all this process. These Miles and Poppers built this to be a continuous foresight process. About the uncertainty, so we deal with the future, so the future is unknown, so uncertainty is there. So the nature of uncertainty is time dependent, which means that when the time goes on, the uncertainty rises and the structure of the problems decrease. So it generates a complex environment. To deal with this kind of uncertainty, Turner proposed a taxonomy of uncertainty, you can see here. So you have an objective dimension of uncertainty. It related to all the information that you can have about the future. This is related to the epistemological uncertainty. So the lack of information lead us to the epistemological uncertainty, and the ontological uncertainty is related to the randomness of the world, which means this part of the future that we really don't know. A subjective dimension of uncertainty is in general related to the feeling of uncertainty and like an individual one. Also, dose and energy defines substantive and procedural uncertainty. In substantive uncertainty, dose and energy defines that's related to the lack of data, lack of information. And procedural uncertainty is related to the lack of processing capacity to deal with this information. So we can relate big data machine learning directly to this to this dimension of uncertainty. Also, there's a lot of other concepts related to uncertainty, like risk, ambiguity, complex systems, bounded rationality, but I will not go deep in these concepts right now. Now, about talking about big data and machine learning. So big data is a massive set of data in terms of acquiring, managing, and processing information. In general, experts classify big data in 6 V's, which means big data has big volumes of data, has a variety of data structure. Big data deals with structured and unstructured data, and velocity. Velocity in terms of generating data, processing, and analyzing. Also, the other 3 V's, veracity, variability, and value, are elements important for big data. In machine learning in general is algorithms that improve their tasks efficiency according to the experience of the training data, which means you program an algorithm, and this algorithm can set their internal rules according to training data that you give to the algorithm for it to learn about the patterns of data and project these patterns for the future. So they are very important tools for dealing with the future. But we can also highlight some limitations of big data machine learning. And I highlight here 4 points. The first one is data quality. We are not sure that the quality of the data you collect when you deal with huge amounts of data. So you don't know the accuracy of the measurement, the credibility of the source, the consistency of data. The second point is data manipulation and biased algorithms. So you need to be sure that you are using appropriate pre-processing techniques to deal with this data, and also algorithms that cannot induce biased decisions. For data interpretability, it's important to know the context that you are analyzing, because only data, analyzing only data, you can create false relationships, and this will influence your decision making. And also a very important point for big data machine learning limitations is ethics and privacy, which means the use of sensitive data, data ownership, application of informed consent for collecting data, and big data divide are examples of these issues. So, based on these fundamental concepts, I proposed two approaches for analyzing the impact of big data machine learning for future studies. The first one was to obtain, it was a bibliometric analysis, and it aimed to obtain a panorama of the future studies that's supported for big data machine learning. The second one, it was a survey analysis with experts. I will talk a little bit in the next slide. So, for the bibliometric analysis, I collect papers about future studies supported by big data and machine learning. So I collect papers from Web of Science and Scopus, and I analyze these papers using text mining and the software Vantage Point. So for getting my specific data, my specific corpus, I collect papers about Foresight and STI, and I got 14,000 publications, more than 14,000 publications. And I also collect papers about big data machine learning. But my main database was this intersection, the Foresight and STI, with big data machine learning. And I collect this data, I clean the data, I classify the methodologies, the affiliations, the funding organizations of these papers, and also I create the graphs and the networks on Gephi and Excel. The second part of my methodological approach was a survey analysis. So in this survey, my objective was to obtain from future studies experts their impression about the impact of big data machine learning in different parts of Foresight process. So for this, I developed 12 future projections, and I divide these projections in the five phases of the Foresight processes. And they are the projections. So I will talk a little bit about each one. On the pre-Foresight phase, my projections were big data machine learning will support objective definition, was the first one. The second one, big data machine learning will guide methodological choice for a future study. On recruitment phase, I had 3 other projections. So big data machine learning will require analytical skills for dealing with this data for future studies. Big data machine learning will support the data collection, and these tools will improve data quality for these studies. In generation, it enhances data analysis. It will drive the qualitative methods of future studies. It means only analyzing data is not only the only method used for future studies. So we have also the qualitative methods. So these tools will drive these methods, and these tools will increase data manipulation. On action, if big data machine learning will support the results transfer, and big data machine learning will increase decision accuracy, and the last phase, it will support study evaluation and support to reach the objectives of future studies. So for this, I sent my survey for more than 7,000 future studies experts that I collect from the bibliometric analysis. And also I share with two futurist groups, is the World Future Studies Federation and the Millennium Project group members. And also in these 12 projections, the experts assessed in three aspects. The first one is expected probability of occurrence. The second one, the desirability of occurrence. And the third one, the impact on foresight in industry if it occurs. So, we have some results from the bibliometric analysis. We can see in this graph that big data, we have this first one is the publication foresight and STI. The second one, the publications in big data machine learning. And the third one, in foresight and STI plus big data machine learning. The last one is the most important for this research. So we can see that these publications are evolving year by year, but they are still incipient. Researchers are starting to use these techniques in future studies. Only 2% of all foresight for future studies for STI publications use big data machine learning tools. Here I present the methodological approach of the papers analyzed. So we can see that patent analysis are the methodology most used when we talk about integrating big data and machine learning techniques. Just one comment, these methods are based on the 33 methods from Popper, 2008. And I consider these methods the traditional methods for foresight, because here in the second graph, we have the big data machine learning techniques that are using together with these traditional methods. And when you talk about big data and machine learning techniques, we can see text mining is used, data mining, and general machine learning algorithms is also used. Here you can see the co-occurrence network of the methodological approach. So it's interesting to see that patent analysis and text mining are used together. It's very strongly used together. Also, it's interesting to see bibliometrics and text mining also connected, because it was the methodology I used in my dissertation also. And you can see the cluster analysis, also patent analysis, neural networks, deep learning, and a lot of different techniques. Okay, for the survey results, I sent my survey. My survey was open from 19 October to 28 the last year, and I got 479 complete answers and 307 comments. The demographic overview of the respondents was 66% of the experts were affiliated to universities. 59% of them had 10 or more years of experience dealing with future studies, and half of them were from Europe. And here you have the distribution of the answers in expected probability, in desirability, and impact on foresight industry. You can see the colors. This one, the red one is very low, then low. The gray is neither low or high. The high and the blue one is very high. So here you can we can highlight require analytical skills are the most has the most as the highest value of expected probability, mean value, and data manipulation has the lowest value, mean value of desirability. That are important points that I will explore a little bit. So to understand these projections, I put them on this graph on expected probability and impact on foresight industry. And this bubble size is the desirability of each projection. And I divided them in 4 groups to better analyze. So the first group are the group with the highest expected probability is the projection 3, 8, and 9 require analytical skills, increase data manipulation, and support results transfer. The second group is projections 4, 5, 6, 7, support data collection, improve data quality, enhance data analysis, and drive qualitative methods. They're here. And the third group has the medium-low value of expected probability, is guide methodological choice, increase decision accuracy, and support the study evaluation. And the lowest expected probability was the first projection, support objective definition, and the last projection, support to reach the objectives. So these 4 groups, the first group, it relates to the analytical competence. So it shows that this competence, the analytical competence, are very important to deal with this complex world that we live now, and to deal with this huge amount of data. Also, the results, the experts consider that the results are better transferred to action. It means are better transferred to policy making or decision making when using big data machine learning tools. However, the data reliability related to the data manipulation can play an uncertain role in this environment. It's not very desirable. On the second group, these projections of this group that are support data, improve data quality, enhance data analysis, are all related to data analytics and the foresight methods. So many of the experts consider that big data machine learning tools will impact the analyzing, collecting, the visualization of data. The third group is a medium-low expected probability. So it says that to define the methodological choice for future studies, big data machine learning tools are not very relevant for this, because there are other criteria like the budget of the study, the sponsor motivation, and the scientific field. However, these tools can influence a little bit on the accuracy of decision-making based on foresight, mainly for forecast studies. The last one, that's the future studies objective, is the lowest expected probability, so it can conclude that big data machine learning does not influence very much on defining the objectives of future studies, and also to reach these objectives. Talking about the uncertainty and based on the bibliometric results and also the survey results, I defined 3 dimensions of foresight that are affected by big data machine learning, effect on uncertainty. On data reliance, so the major limitation of big data machine learning is the reliability of data. It means you can bias, you can make your data biased when manipulating this data, and when you are not sure about the source of your data. So this can raise a little bit the uncertainty, the substantive uncertainty of your study. However, the data method integration, which means put big data machine learning tools and techniques with the traditional methodologies for future studies, can diminish the procedural uncertainty, and also the decision making could be, the uncertainty related to decision making could be slightly diminished by using big data machine learning techniques. On the final remarks, so big data machine learning tools is still quite restricted, at least on academic literature that I use it on my bibliometric analysis. Only 2% of foresight studies use big data machine learning. And it's observed that the frequent use of big data machine learning use patent analysis, time series analysis, scenario modeling, and bibliometrics are the methodologies. And for big data machine learning techniques, they use text mining, data mining, and general machine learning algorithms. And also, the 3 important points: future studies will require analytical skills to deal with this massive data, transferring the results of future studies supported by big data machine learning is better, is more efficient. That means the use of this study for policy making or decision making are increased. However, the data biases, the data manipulation, the data reliability, it can act as an uncertain factor in this point. And that's it. That was my research. And I will be very glad to listen from you professors, your impressions and your comments. Thank you so much.
Thank you, Vinicius. Maybe you could stop sharing your screen. Thank you. Thank you very much. So let's go directly to the discussion. I would invite Professor Abdulah Gok to make your comments, and then Professor Dirk Meissner. Professor Abdulah.
Thank you very much, Sérgio, for inviting me.
The stage is yours.
Thank you so much. It's my pleasure to be here and to listen to this presentation. And Vinicius, thank you so much. It's really a fascinating topic, I would say. Something that I have been really wondering myself as well. What these kind of new data methods and available of data, how these kind of new methods would impact foresight. So it's very informative. And I think your presentation kind of reminded me some of the epistemological undercurrents in future studies. So I think there are a kind of number of different approaches in these kind of studies. I think you have in one end foresight, you have in another end forecast. You have some people who think these kind of studies as kind of a method to predict the future, or a method to shape the future rather than purely predicting it, a kind of a discussion and a kind of a collective shaping of the future tool. You have approaches within foresight that sees foresight as collective intelligence that occurs in different people, and you need to bring that kind of intelligence from a kind of a number of people. But also you have approaches that sees foresight as discovery of absolute truth, even though this is quite rare. And you have foresight also on different domains. You have foresight in generally science and technology and innovation. You have more specific applications of foresight on technology assessment, for instance, or you have foresight in application of non-technology areas. with road mapping and other methods, scenario studies, and so on. So I think while the topic of your paper is really very interesting, I think the analysis really depends on what kind of approach, what kind of foresight you are talking about. At the moment, it seems to me that you put all these different approaches into one basket and try to see the impact of these kind of new methods on all of these different things. But maybe there's no one basket. There are, as I mentioned, slightly different things within that basket of future studies. And maybe the use of this kind of data has different implications and different seriousness for these kind of different approaches. So I think that's the fundamental issue that that I have with this paper. It needs to be a little bit more specified what kind of foresight you are looking for, because really the impact of these methods and implications of them depends on what kind of portion of future studies that you are looking for. Okay, this is kind of the half of the story. The other half is really the big data, the term big data. As you all know, there's no one single definition of big data. It's really very contentious. There's the simple definition of 3 V's that people tend to use, but even that is really very relative. So it is relative to context. So what you might call big data in one context might not be big data in another context. So some contexts have been using these kind of approaches for a long time, and they are more kind of conducive to do these kind of approaches, but some other contexts have less and less data. And we see generally the social phenomenon has less data, and you see kind of less big data in social phenomenon than physical phenomenon, where data collection is more readily available and the methods are more established. And also there's another dimension to big data. It is also relative to time. So what you have done, for instance, a bibliometric analysis of a few thousand papers was big data 20 years ago. It was not possible 20 years ago with the data available to us and the methods available to us and so on. So it is also relative to time, what you call big data and associated techniques. So I think also you need to distinguish what big data might exactly mean for foresight. I think you are again putting maybe too many things into one basket. So there's a quantitative tradition in foresight studies, always some advanced statistics. Would you call them big data now? Would you call them big data 10 years ago? Bibliometrics, would you call them big data or patent analysis 10 years ago, 20 years ago, or now? So I think this needs a kind of a better definition or what you call big data. Maybe you might want to kind of focus on, rather than big data, really kind of data-driven approaches that might be a kind of a more suitable and kind of a more less relative concept, time relative and context relative concept. So given this, these are the constructs. Yeah. So you have two elements. You are trying to understand the relation between foresight and future of foresight and the big data. So these needs to be a little bit more kind of specified and defined, so that the contributions are clear. On practical elements, so you have two methods. One is a kind of a bibliometric method, and the other one is survey of experts, almost like a mini Delphi, one round Delphi. So I think this is good. This is what you can do with the current data. But you, by using this data, you run into risk of maybe not capturing the practice itself, because practice is not academic in academic papers. So how foresight studies are conducted really outside of academic papers, because most of these academic papers are about methods and methodological developments or some conceptual papers. I think there's little material about the real practice, the industrial practice of foresight. Again, it depends on what kind of foresight you are talking about. If you are really talking about, for instance, more scenario analysis or road mapping, the academic papers are more conceptual and maybe methodological. Whereas in other areas, you might have some more practice papers in academic areas. But overall, I think you have less kind of practical kind of papers coming out of practice, documents coming out of practice in publications. And also, I think if you, anyway, if you are to do a bibliometric study, I think you would maybe define the parameters a little bit better, because we know not every paper are same. They are published in different journals. They are published on different disciplinary areas and so on. I think you need a little bit of more specification and maybe a little bit of criteria of what kind of journals that you include or not, and what is really the criteria of including. Do you include articles, for instance? What do you include? Review papers and so on, or conference papers and so on. Maybe it is there, but I didn't see in the paper. But maybe a specification is kind of needed. So survey, I think it is a good idea, and you have fairly good kind of response rate. You have sent about 7,000 people, and you have responses of 500 people. That's not too bad. 500 people response to a survey. But the problem with the propositions and the answers to survey is again lies on that unspecificity. So do you see, and again, it's related to how you see the foresight studies. Do you see these methods in one extreme, replacing all this collective intelligence and kind of creating a kind of a foresight that is only driven by data, almost like a forecasting method? Or do you see these kind of methods, on the other hand, helping a kind of a foresight as a collective intelligence, foresight as a future shaping activity? And there's a lot of spectrum here. So these are the maybe extremes. And depending on where you are in the spectrum, I think the questions are kind of different. So is it a kind of helping tool, or is it something that is going to replace the human intelligence, human collective intelligence? So you can really kind of design all these questions that you ask to experts quite differently. And maybe the results might differ as well. So I think that needs to be explained as well. And I think that brings us to the conclusion, which has really a kind of a great potential. That can be a discussion of what kind of future of foresight that you are seeing. I think at the moment, the discussion that you have is good, but it's maybe very operational. It really depends on kind of the operational issues, how this data can be used, how this data can help. But maybe there's a point here to make a discussion about a kind of a more grand kind of a discussion conclusion. What is the ultimate role of these kind of data methods? Will they replace human intelligence? Will they alleviate the need for kind of foresight as a shaping future? Will they provide us to a kind of ultimately a kind of discovery of an absolute truth as a kind of a really kind of a linear future kind of an approach? And I think this again depends on your construct at the very beginning, but there might be kind of a room maybe at the very end for a even grander kind of a conclusion beyond all these nitty-gritty operational things that you have done, which are important as well. So in conclusion, all in all, I enjoyed this paper. It is kind of a really important point. And I think it might be a good paper, a really great paper with a little bit more clarity, kind of more specificity, and a bit of kind of more grand and conceptual discussion. Thank you very much.
Thank you very much, Professor Gok. The excellent comments, and they help a lot in order to improve this manuscript. This is the idea, really the idea. Thank you very much. I think I can pass directly to Professor Meissner. And I believe Professor Meissner has a presentation, a short presentation for us. Please,
yes.
Dirk, feel free. The stage is yours.
I thought it's better if I write on my thoughts. So I hope you can see it. All right, so it should work now. Now the future studies. Foresight is also an issue. If you just reflect what is in place, and it refers definitely to what you taught us and presented earlier. I think this is a very long tradition, and there's a lot of different tools. The only thing which is a little bit more critical in my view is foresight is being discussed in academia for the sake of foresight. If you look at the corporate sector, if you look at companies level, let's be realistic. What happens there for the last decades? More than decades, many decades. They call it long-term planning, strategic planning, etc. This is nothing much different from a foresight exercise. So what I frequently see in the foresight discussions and debates, we are developing scenarios, we are doing roadmaps, and so on and so on. Okay, in a different context, in the management literature, we see it frequently. This is the simple, what you learn becoming a consultant, when you hire from McKinsey, just consulting, what you could order, what you little, what is consulting one, teaching at the very first day which you learn. This is a very harsh statement, of course. What we find necessarily clearly is we have a lot of issues related to uncertainties, and you stressed the point about uncertainties. So whatever you're doing in terms of scenario development, whichever tool you involve, you come to the point there's uncertainty. There's not a likelihood. You cannot really predict which way or which scenario is more likely. We saw that a year ago, also this year, many people were asking the foresight practitioners, why didn't you predict the COVID-19 breaking out? This is a good question, of course. Because that also shakes a little bit the manifest and the foundations of foresight. It should have been somewhat on the radar, but it wasn't. That leads to other problems of foresight about communication, about visualization, and all related issues. What else we saw is that foresight certainly increasingly used also at the regional level, especially in line with the smart specialization high. We might think about smart specialization what we want. I'm not a big fan of that in that sense. I believe we need a little bit more elaborated, sophisticated issue here. But foresight is usually taken more or less as a strategic planning tool, finding a niche, trying to predict a niche for competences and qualifications of a region, which might conquer over the years. And the second issue is at a regional level, even worse at the national level. There's such a huge, complex governance structure. At the national level, there's also of no use running a foresight exercise if it's just done at the presidential office or the prime minister's office, or so what. Somebody has to implement that. And in order to implement that, you need to gain the momentum, you need to get the support of everybody involved. And last but not least, we see from the current status that foresight is pretty much confused with the assumption that you're predicting the future, which is wrong, which is definitely wrong. But even maybe it's an issue changing the term foresight or replacing the term foresight. It's very much covered by the impression, okay, we are doing foresight and they'll tell us how the world looks like tomorrow. So what did we see over the last 5-10 years arising? Increasingly, we had a big debate about the personal bias and the strategic or the hidden agendas of people involved. Now, let it be the case, assuming everybody is open and saying, giving a real nice, unreflected assessment of whatever technology problem, whatever you use in all this scenario building, the workshops, you will never avoid the personal bias. And it has many, many different facets. So this personal bias to overcome, machine learning, big data analytics is certainly one tool, because there what you can do is with an increasing information source and data sets of different nature, not compatible, not all in Excel sheets, but many, many different. With these approaches, you have a little bit more solid and a more evident database, which helps when some people start assessing, helps overcome their bias, because then they have to lie, obviously. So I would call it like the hidden agenda of people involved, which you don't detect at the first sight personally, but has a long-term impact. So what can we use this machine learning for? First of all, for the validation of findings, and certainly also for inspiration. So if you have something to present with some impact, with some evidence, and you can say we see it from the semantic analysis or whatsoever, that creates also a momentum for inspiration and creativity. So you're not starting from the scratch, not starting from a white sheet of paper, but you have something in your head, you start discussing. So you probably shorten the very, very first stage. Second, so far, the results are usually very, very much weak or qualitative nature. Now, increasingly, with these IT solutions also, they're coming to a stage where we have more possibilities to quantify results. But especially, for such studies at the national level or the regional level, what is needed is something tangible. So who cares about a statement, very likely, but nice thing will happen. So what? If you know it might happen, you want to know how much do I have to invest, what is my return? So for the policymaker level, always bear in mind we are spending taxpayers' money, and we have to justify why to spend the taxpayers' money in a certain field. But you can justify that, okay, it returns, it gives a return and a regional impact for whatever purpose. Thirdly, this is a strong issue. A foresight study is usually, I don't know how many hundred pages long. Who finds the time to read that? At the moment you start reading, and when you're finished reading it, it's already outdated because the world is running and moving around. So what you need is some very compact, comprehensive visualization tools. Here I also would argue, when you talk about these semantic maps, for example, this is not a tool to visualize. It's wonderful to watch, but it takes you long, long hours, even not days, or even more to understand what is shown in this map, because it's too much information for a simple brain, a simple human brain, to understand, digest, and draw a really conclusion. Last but not least, there is currently, again, now a hype about conducting such foresight studies in regions and in countries. But as Abdulah rightly stressed, there's so many, everybody's doing for different purpose, different approach, etc. It's pretty hard to compare that. And this is the important point. When you start looking at a foresight study taken in, say, a European country, you can hardly take the results and implement the results in Brazil or in Russia, because the ecosystem is a fully different story. You might get some potential trends, and you might get some idea what are the others doing, what do the others think, how the world might go like. Could be the case. Nice inspiration, but it's not so easily to implement in your place. So what do we actually require in the future for these foresight studies? And these are all the facets I found in your work, in your paper so far. Number one is an acceptance, a real acceptance. So that is probably not done with a public relations campaign, but it needs to come from heart. So you need to demonstrate an effect. The more foresight studies you do without demonstrating an effect, the more tired people get. Because everybody knows that the moment the foresight study is finished, it's almost a little bit outdated. So how to update that frequently and not producing tons of papers and materials, nobody really cares. It creates another bureaucracy. So Some people might not like what I'm saying. I hope my boss is not listening to me. All right. Second is a question about understanding what is this foresight about, and what is the real value in the end. So that means we are coming to the third bullet point. This is about implementation. So if you have a clear idea what you want to achieve, and I believe here foresight needs to undergo also a paradigm shift, not being a blue sky exercise, but being an exercise to say, this is our goal, we want to achieve that goal, and now do a long-term planning. How do we enter that path? That goes more or less for the roadmap in the end as a practical tool to implement that. Now, the challenges arising are pretty obvious. The first is a question about the scope, be it a level or be it a technology field. There's a societal challenge, a political challenge, and I believe policy foresight is the most difficult thing to undertake. This is much driven by, we don't know which forces ever. Second, there is an issue that in each foresight study, you will have a lot of different events to help on trends, whatsoever it is. And when you come to the question, which trend impacts which other trend? How do they interrelate the different events, the different features? What about causality? Just remember when we said nicely the chicken-egg problem. What is first, the chicken or the egg? So when you start interpreting, yes, so the virus caused the illness. Oh no, first I was ill and then the virus appeared. So which way does it go? But this is important to get an understanding where to intervene and how to intervene to improve the final situation. What we need is, and I believe here the big data is a big help for improving the estimation and the likelihood, the probability approaches to quantify this, to quantify that. I remember very, very long years ago, I looked at the financial literature. Black and Scholes, they did the unbelievable. They had their formula to develop a price, the option price, for something which is similar in a sense. But Black and Scholes would not work here, the foresight instant circumstance. But we need some smart mathematicians giving us a tool in the hand that we can more reliably assess the uncertainties and the likelihoods. Now, last but not least, the usual stuff that goes about with stakeholders, and you saw it in your survey. Probably everybody tells you a similar thing. But I still believe is, not quite sure, but what I still believe here is the recent trust in big data analysis, that big data can do everything which the ordinary standard foresight did 10 years ago. This is a bit misleading, because still, when you do a big data analysis, this is a wonderful thing, but you come to many, many statistical findings where you're wondering questions or whatsoever it is, and you start wondering, what is this? A machine is still a machine. So artificial intelligence is not that developed yet, but it can replace the tools and the capacities of a human brain to interpret the findings. It's about the interpretation, and that is crucial for the implementation. So we have two sides. We have one side, it helps us to quantify, and that is absolutely needed to convince all the stakeholders. At the same time, it gives us a little bit more inspiration and room for interpretation, for an evidence-based and more solid decision-making in the end. Right, so that's from my side what I saw now so far. I will stop sharing the screen. And yes, good luck going further. Write a nice paper, and I fully agree about papers in the foresight domain. What we desperately need is something substantial about the methodology. Because what we see the last 5-10 years is all the same. So it's not much progress in the concept development. But that's probably desperately needed.
Thank you very much, Dirk. Excellent approach. I guess we had here two complementary comments, two complementary approaches. and I assume we will discuss them a little bit more. Just asking if Professor Vornortas wants to make some comments before we get to the questions from the floor.
Can I share my screen?
Yes, you can, of course.
Okay.
I don't know if you have
as Vinicius was talking, I thought of this thing. This is a graph from a report that we did some time ago, 2-3 years ago. It's not ours actually. It's from Sterling and Schoons. It's adapted from there. But this is the graph that helps me think about what big data might be doing. And you see what it's a 2x2 kind of thing. The horizontal axis shows sort of dimensions of understanding the goals. Are we clear about what the goals of a program, a project, what they are, or we are not? And in policy environments, you tend to not be very clear. The policy decision makers want everything, want to achieve everything with policy. So unproblematic means we are clear, fairly clear. Problematic means we have ambiguities, a lot of ambiguities in this respect. And then the vertical axis is the technology. So is the technology fairly well understood here? Or we are looking into the long future and so forth. So unproblematic, fairly well understood. In other words, the experts can make reasonable assumptions about when we ask them. Really it's not well understood. In this, if you take things in these two dimensions, you will see that there is one area up here, upper left, of studies that looking forward and try to assess the future, which is fairly well understood. In fact, the past 10, 15 years, we have seen a lot of very good methods being developed here to address risk. Really very interesting. One I have worked, the options theory that Dirk just mentioned. The options is right there, but there are several others. As you leave this comfortable, fairly comfortable box, there is uncertainty, there is risk here, but there is all this. But as you tend to go that direction or that direction, you start getting into moving sand, and that's where the state of the art is now. People are trying to push the frontiers of understanding this direction and that direction. When you go down here in this fourth quadrant here, we are ignorant. We can draw, as Dirk was saying, some nice maps and they look good, but what do they mean? Actually, there is a lot of uncertainty. So for me, when I think about the possibilities that big data may be opening, is if you think about a sort of a frontier where my cursor is right now, if this is the frontier that separates the fairly well understood from the less well understood, the big data hopefully will help us push that frontier down and to the right, in all these directions. So more and more of what is ambiguous or not well known at all will sort of enter into this beautiful upper left part of the graph, where we are much more comfortable and to deal with complicated models, and that's it. That's sort of a way of looking at the problem that helps me. Okay, I will stop here. Thank you.
Okay, thank you, Nick. So we have some questions from the audience. I will pass some of them just to increase the scope of discussion here, but not all, unfortunately. And then we will take all these questions and give to Vinicius and to Abdulah and Dirk and Nick, okay? So one question, it is for all panelists, all people, besides Vinicius, also for the commentators, is there a potential for using technology to increase collaboration in future studies? Is there a potential for this, for using technology to increase collaboration? Let's see another one. Does any of the presented works explore that subject or identify any trends related to collaborative future studies? Is the same person, Beto, that asked this, and some other people are asking about the use of big data and machine learning decision making. I will give the word to Vinicius. Just Vinicius, very quickly, please, your comments, and then we get again for our commentators, and then we
okay,
finish the.
I want to cite two papers that were very important for me to develop my research. The first paper is from Victoria Kaiser, and about the use of big data machine learning in scenarios. That's it, the question. And this researcher, she applies and developed a whole methodology and a framework for integrating big data machine learning techniques into these traditional foresight methodologies. So she describes all the way along the foresight method, the scenarios methodology, and in which points big data machine learning could help. In general, these tools help to get for people, support people to get insights and to get ideas and support this shared vision of the future. About the second question, about the collaborative, the collaboration in future studies, an author, Van der Gracht, he wrote a paper about using ICTs, general ICTs, for developing future studies, for developing foresight. And one of his conclusions is that these tools are very important to improve the collaboration between the team and also the experts in developing these studies. I can share also these papers, these two papers with the people who asked. And yeah, that's my answer to this question.
I don't know if you want to make more comments about the Abdullah's and the Dirk questions.
Yeah. So for Abdulah, I intend in my research to explore. I understand that it's a little bit general when I talk about future studies, but in general, I intend to assess the impact of these tools in exploring the future in general. I know it's a very big scope, but we can still take some outcomes from this analysis, because in general, when you talk about foresight, that you are not predicting something, but in general, you could make some forecasts for analyzing, for getting information, for discussion, in generating in foresight analysis. Also, it's a real limitation in my study, because I only used the academic papers when I was analyzing future studies with big data machine learning. But hard to analyze non-academic future studies because we don't have a platform or a source of this kind of data. And I know that's very important because in general, I used to work in a consultancy company making foresight studies, corporate foresight. And I know this is a very important part when we talk about future studies. But yeah, it's a limitation of my study right now. And yeah, I think that's are my comments for now.
Okay, thank you, Vinicius. We also have a question here: how big data and machine learning techniques can be used or have been used to scenarios studies. So specifically, it's a question about one of most known techniques, which is the scenarios technique. I don't know if you want to yes, Abdulah, please.
I think the question is good, and maybe kind of highlights something that might add to the paper. Why didn't you consider, for instance, to do a few case studies? That would really add a lot of value to your paper. I mean, why don't you take, for instance, a few foresight studies that you know that uses these kind of data, big data kind of an approach, and to illustrate how they use the issues and how they kind of open possibilities, but also kind of created issues and so on as well. I mean, there's kind of that very famous, it's not exactly foresight, but really very famous story of Google flu trends. I don't know if you know it. It's really very famous in big data kind of domain. So Google flu trends, it was a tool, especially in the US, 2013, 14, 15, around that time. So the idea was that Google was going to predict the flu season by using some sophisticated technique based on the Google searches. So if people start searching like how to home remedies for flu and whatever, it might be a kind of an indicator that the flu season is coming. So that was the basic idea, but there was a little kind of complicated data, big data kind of stuff behind it. So it was hailed as a kind of a really very important, the future of big data is a kind of a poster kind of an application for how big data can change our world and so on. But it failed dramatically. And there are lots of studies why it failed. And there are some technical reasons why it failed. So it overfitted data and so on. But also there were some kind of human interactions, human reasons, social reasons, why this tool could not predict fairly basic thing, predicting the flu season, which happens every year, slightly different time, slightly different seasonality and seriousness. So I think there's a literature. What might be the critical factors that makes the use of big data successful in a kind of a broader context? So you can learn from that as well. And by doing a few case studies of foresight studies, some of them industrial, some of them are more academic, kind of national level studies, then you can maybe talk a little bit more with confidence about the subject matter of your paper. Just an idea.
Yeah, thank you, Abdullah. I think this is really a good idea. So in this way, we can go towards a more detailed analysis of in which situation, what are the conditions, the context that the big data can work better in, and under which conditions. We have also here the famous $1 million question. And we'll take advantage of your presence here to discuss how to measure the effectiveness of foresight efforts. If PD, ML, big data machine learning can help in this sense. I mean, measuring the effectiveness of foresight studies. And this is the $1 million question ever, no? We have lots of foresight of prospect studies, but normally we do not go afterwards to see what happened and how the foresight studies were really important or effective in terms of decision making and policy design and the results, the outcomes that can be measured from the policies, the programs, etc. So maybe one of you could talk about this, the effectiveness of foresight study and how to get to them. Dirk, please.
Yes, I think in principle, what you can do is just take previous foresight studies and have a look what really happened. So you can take them and you can compare them. If you had a 10 years time horizon, okay, you take those who were prepared 10 years ago and you compare what we predicted, what we had in mind, scenario like or events like, and what really happened in the end. This is a very simple approach. Unfortunately, the world has changed in the meantime, so you cannot really go back and say, because we took the following measure, now we see the effect. This is not linear. So the measures, any policy measures which you might take to intervene based on such a foresight study, you have some election campaigns or election rounds in between. That means you change the policy. So there isn't any policy which lasts over the next 10 years, except in fields where we come for mission-oriented research, like the very big scale, take ISS, take CERN, such big things. Okay, this is sustainable long-term. Anything else in policy domain, in policy measures, well, if it's longer than 2 years, it's already extreme long. So the time horizon for considering the validity of policy measures is becoming even shorter. That makes it mission impossible indeed to give an assessment, was the foresight study effective? And effective, this is always a big issue. What is the difference between effectiveness and efficiency? It's always often being mixed. So it's highly efficient, but effective, no, you didn't reach your goal. That was a question about measuring effectiveness. Well, what is the goal written or designed, defined in a foresight study? By purpose, it's rather broad. It's nothing tangible, quantifiable, that you can simply break down and say, now we measure it. It depends on the perspective you look at the goal which you formulate. So, and if you have different perceptions of a goal in the beginning, how to measure the effectiveness then from different perspectives, that creates another set of scenarios. And in the end, everybody is happy because he's feeling well in his own scenario. But there is no consensus at all. So about effectiveness, I really have many doubts about measuring that, because so many events happen in the meantime which impact all the policy measures and change the line and change the targets. Plus, there's one more phenomena which we see in STI policy. As a matter of fact, politicians are doing nothing different for the last 100 years. The only thing they're doing is using new words, new terms. So the same policy measure over many decades under a new logo, under a new label, and that's it. So we are not so smart inventing the policy mechanisms again and again and again, improving them. A little bit fine-tuning, yes, new label on top, we think it's all nice. But because we have these different labels and different wordings, it's even more difficult to trace back what event or which measure created which impact in the long term. So this makes it more fussy. Maybe if you go for, again, this big data stuff in the natural language processing, it might be possible if you if you trace it back, when you get a big basket of different logos, different terms for the same concept. That might be a solution. It's a bit artificial intelligence included, with some human intelligence assistance. Might be an effort.
Yeah, I think so. Let me tell you a little bit about the origin of this theme of this research. The research Vinicius carried out is this. It started when we had some years ago read some papers saying that, well, now with artificial intelligence, with the massive availability of data and the increasing capacity of computing. So now we can finally have methodologies that can predict the future. So some people have said that, and so the original question for the Vinicius research was really this: to which extent uncertainty will decrease if you have more data, more enormous quantity of data, enormous volume of data, and increasing capacity of computing. And there are some articles saying that for the short term, in terms of decision, in the short term, that have most of the variables that are involved in that decision are known or more or less known and cannot change very much in a short period of time. There are differences. So some papers, some authors started measuring the efficiency of decision making based on evidence, based data-driven, and comparing companies that have made their decisions based on evidence-based data-driven decisions to other group of companies that were not doing this. So they found, for instance, 7% more profitability. So they went to some indicators that could be correlated with decision-making process in these companies. And so the original idea is, are we really decreasing or seasoning uncertainty if we use more and more data? And the conclusion of Vinicius' thesis, and we didn't know, we didn't really need a thesis to prove this, because uncertainty is a definition in its own, in terms of it's an absolute word. No, it's an absolute concept. But the conclusion is that maybe in some cases you can increase the conditions or improve the conditions to make a better decision, because there are some variables that will not change a long time. There are some variables that you know how they will perform in a short period of time. There is no big possibility, great probability for entering new variables that you don't know how they work. And in this case, maybe that's true, can be true. But in terms of, if we go out from this scenario, from this perspective of knowing the variables that are involved in decision-making process, when the more open is the system you are looking at, the more will be difficult to have, of course, all the data you need to make better decisions. And whatever the capacity of computing, whatever the capacity of getting more and more data, uncertainty is still there. No? Even the possibility is that the more you know about some issue, some scenario, some horizon, for instance, the more you will need data in the future. That means maybe there is a hypothesis that the more you go for data, the more uncertainty in the long term will increase. So this is the contrary, no? The opposite situation. I mean, having more information about something means that in the future you need still more information in an endless process of that maybe can indeed increase uncertainty. So this is more or less a more philosophical position, but it's quite interesting in this discussion of future studies. Please, Abdulah.
I think that's perfect kind of a conclusion for that kind of a paper. I was really expecting to see that kind of conclusion. And then I think when you make that conclusion, the next question comes to you. Will this kind of techniques help us if they help us, under what conditions and context they help us, under what conditions and context it will even complicate our job. What kind of skills do we need? What kind of questions we need to ask to be able to use it? And how do we deal with that human interpretation later on? And that is kind of the valuable, real kind of valuable question, because what you are saying is really very intuitive. We know all about that already. We can expect this kind of a result. But what we don't know is that under what kind of conditions and context we can use this kind of stuff, and under what other contexts and conditions this is even complicate our job.
Yeah, yeah. This is something that I think this is a good frontier, you know, to increase or to study more and more, because my perspective and my feeling, it's a feeling, Abdulah, because we do not have yet enough studies to prove this, but I was also talking to a physicist, you know, a guy that works with black holes. You know, the idea is there are some similarities between this idea of something that you really don't know what is in the future, in this case, the black hole in that case, and the horizon of events. You know? How to define this. And maybe we can develop some models in this case, and how to develop some, it's calculable, in which sense can be calculable this, can be calculated. In this sense, this is a frontier of studies that we also want to go to in the future. Okay, please.
Last comment before we go. I totally agree with this tone of the discussion, and from the very beginning with the comments of Abdulah here. And that's why I showed that one graph. This will be critical in order, I think, for the next step. You must find the better way, the best way, or a good way to sort of parse the different kinds of studies, the different areas that you want to tackle in order to address this question, in which those areas the big data will help us and which areas it won't. Right?
Yeah.
This will be a critical milestone in this endeavor now.
Yeah, I think this is a good research question. Abdulah, please. Thank you, Nick.
Mm-hmm.
I think I'm totally in agreement with Nick. And I think this is a story that we know already, because if you know the big data literature, there are lots of, maybe not specific on foresight or anything, but there are lots of similar questions. Will big data replace scientists? Will there be a kind of an artificial intelligence that makes all these experiments and calculations without the need of humans? This is a kind of a long line of literature in big data. Another line, I'll give you an example. There were lots of research, I think about 10 years ago, on computational intensive trading, kind of financial trading. Can we trade by not involving any traders, but just computers, by using models, by using big data, social media feeds, Wikipedia? There are so many papers on this. And the result was that in the short term, you can make profit with this kind of computational intensive trading, but in the long term, you need the human intuition. Again, I think the results for humanless science kind of literature was that you need humans for creativity, for intuition, and also for theory, because any kind of approach needs to be theory-based to be in the long term successful, and humans bring the theory into the picture and the machines make the operations. And I think maybe there are kind of lots of lessons that we can learn from this debate, how we can then port this data story into this specific context of trying to predict the future.
Yeah, this is a fascinating area of research, fascinating, and I would like to emphasize this in the near future. This is the future of future studies, actually. Okay, So I'd like to ask if Vinicius wants to make any final remark, Vinicius.
Yeah, I think that I'm thinking about these different kinds of future studies that we can think about the influence of big data machine learning. And in general, I think that when you less structured problems, and I think this kind of tools could be very assertive and very helpful for the decision making. However, when you think about the foresight, for example, a more general future, when you have several different variables and you need human insights for thinking about the future, these tools help on analyzing data, but for the decision making is still on people that base their ideas, their insights on this data, of course, but they are people. So I think on the Nick's figure, on foresight, thinking about foresight, we never came to this risk-based, because we always have this ontological uncertainty, these things that we never know in the future. And yeah, we try to get closer to the risk-based problems, but yeah, it's hard. So that's it. That's my final comments. Thank you, Professor.
Thank you, everyone. I don't know if Abdulah, Dirk, Nick, if no more questions. So first of all, I would like to thank you all for coming, for taking part in this webinar. This is the first of a series of webinars we are organizing here at Unicamp. And the next one, I would like to invite you all is still over big data, but now in a hindsight for evaluation, the use of big data for impact evaluation overall. And we will have two well-known people talking about this area, who are Michael Bamberg from Rockefeller Foundation, which is a very well-known scholar in this area of evaluation, impact evaluation, and also Rodrigo Costas from Leiden University CWTS Center in Leiden. So they are presenting us the recent developments in using big data to evaluation, impact evaluation. So you are all, of course, very welcome, invited, and we are going to send to you the prospects and the announcement of this next seminar. So again, thank you very much. Thank you for all the audience we have in the YouTube. Thank you, Vinicius, and I hope we get together in a more few days, this 4th June in this new seminar. Thank you very much, guys.
Okay. Thank you.
Take care. Be
Thank you very much.
Healthy. Take care.
Take care.
Thank you, Dirk. Thank
you.
Abdulah.
Thank you.